Now, let's start with iMod, and let me see if I have another. Yeah, try a different setting at once. Okay, let me start with iMod, and given that last time I realized that when I loaded the data there was some problems, I would like to start from the beginning, from the loading of the data, okay? And unless you tell me that everybody already loaded the data and there's no problem in doing that. And if you But let's try to start from the beginning. I think it's the best thing to do. Let me see, just make a check in the camera if my face is within. Yeah, unfortunately not. Okay. Should be in the video now. Now, let me see if I can connect. Unfortunately not. Just 1 second, I'm trying to connect, otherwise I can do in a different way. Okay, good. Now, let me start then. So we have to upload basically the river flow data and rain and evapotranspiration. And let's assume that you already saved this data in a file. And this can be done in many ways, because when you click on my website, you take the data on the browser. And this can be done in many ways. What I do is to select all, from the browser. You see that I'm working in the browser now. I select all, and then I right click and I select copy. So 2 right clicks, select all and copy. And then you have to open a text editor, and like Notepad if you have Windows. I have Linux and therefore I take another one, but you shouldn't be concerned. This new text editor is that I opened here is like your Notepad. And then you right click, paste, and then you save the file. File, save. And I'm saving this file as rain evapo. And that's it. Let me check if everybody is following me. Are you? It's fine? Perfect. So basically now I can close this Notepad or text editor because I don't need it anymore, and I can close this window in my browser. Good. Now it's, sorry, I close also this. Now we have to take the river flows, and the river flows again, select all. Right click, select all. Right click, copy. And then I open the text editor. And then in the white window, blank window, right click, paste. And then I can save. And this is saved as flow.txt. TXT. Okay, I had it already. I can close the text editor. Okay, so I can close the text editor, and I close the window in the browser. Now I also open the code, and let's save the code in a file, because it's much better, it's more manageable. If we want to make modification changes, it's more manageable. So I repeat the same procedure. Right click, select all, and then right click, copy. I open the text editor, right click, paste, and then I can save this file, and I save it as imod. Let me change the directory. I change it in imod.s. The name doesn't matter. Or let's call it R, imod.r. The name doesn't matter. Good. Now I can close the text editor, and I close the window in the browser. I just would like to check now if everybody's with me.
We don't have all the connections, so we have to pass it.
Okay. Okay, I wait for you. By the way, I just uploaded this morning, sorry for the delay, the videos of Monday. Monday's videos are uploaded. So here everybody's ready, okay? Good. Molly? Ready? Okay. And I started again the exercise of the annual rainfall runoff model. And you don't have the PC?
No, sir, actually, I think I told you on Monday that I'm not following the use of the software, so maybe I have to read because since the commencement of the course,
Yeah.
I have not followed this session.
Ah, okay. So you mean you didn't follow the exercises? And wasn't it clear on Monday that today I could have...
I think I left before you.
Ah, okay. Sorry for that. Because at the end of Monday I didn't, I just went forward with the theory and we decided today to dedicate 3 hours to the PC. And on Monday I will dedicate 3 hours to theory again. And I think on Monday I should close with the theory on Monday. And then I will teach again on Thursday, again on PC. I'm sorry for that.
No problem. So we'll meet on Monday.
Yeah,
Thank you.
sorry, no problem. Okay, so let's start now the R session. And given that you are only 6 people today, I think we can make an effort to move forward all together. So if you get behind for some reason, just let me know, okay? So now let's try to upload these files, and let's start with the easiest one, which is the river flow. And let's call it QoS. Because in the program you may remember that I called it QoS, so it's better if we use this name. And we just have to use scan, and the file is, I called it, I don't remember, flow, I think, yeah, flow.txt, and then we have to skip a couple of lines. Not a couple, 2 lines. Yeah, and we are now ready. Perfect. Can I move forward? Good. Now, a bit more difficult, it's the uploading of rainfall and evapotranspiration. So let's start with the dummy variable, PR1, and scan rain evapo. And here I have to skip 3 lines. You remember that here the trick is that we have uploaded the data together in the same vector. And therefore now the trick is from the vector to create a matrix in order to have in the first column the rainfall and in the second column the evapotranspiration. So basically now we can do like this. Let me change the name of the variable, then we remove them. PR2 equal array PR1, and then we have to give the dimension of the array. And the dimension is 28760. Good. And then I can create a variable P, which is evapotranspiration, rainfall, which is equal to PR2 first column. When you put in the dimension of the matrix only 1 dimension, and then you leave empty the second dimension, it means that you are getting all the data that are included in the, let me say, second dimension. You don't specify the second dimension, and therefore you include all of them. And just to check, let's plot the first 10 data of the obtained vector. You see they are a sequence of zeros, which means that we are done. It's okay. Because you may remember that, because you know here the problem, the doubt that one always has, is whether or not the data were rightly put in the first and second column. Because when you specify the dimension of the matrix, I always have the doubt if I have to put the lower dimension first or second. So if you, instead of putting a dimension equal to C2, 8760, instead of indicating that, you indicate dimension equals C8760 you mix the rainfall and evapotranspiration data. So basically, you always have to make a check if your reordering was fine. Given that it seems it's fine, now let's get the second column and in the vector EP, potential evapotranspiration. So EP is equal to PR2, 2, and let's make a check, EP1, 10. You see that it's fine. Good. At this stage, we can remove PR1 and PR2. Perfect. Okay, very good. Now, the next step is to upload the program, the function imod. Next step, as I said, I'm doing another thing now, just 1 second. Next step is to upload the function imod. And let me open the file in a notepad, text editor, whatever. Here is the file. Let me expand it. Good. Here is the file. I just take it open because if we want to change, make changes, change something, it's useful to have it open. And one other issue. You may remember that we decided to skip the first couple of thousand of data because, as you may remember, we noticed that they are difficult to simulate. Okay? So, let's do like this. Let's put in the number of time step the whole series 8760. And so, how can we skip the first couple of thousand of data? I think it's a smartest solution, let me say, to change here the limits, I put it a little bit above, of I. Let me start from I equal 1900. I'm just starting forward, not at the beginning of the series now. I'm starting forward 1900 data. I'm moving forward with the start of the simulation procedure 1900 data. This is the smartest way to skip the initial part of our time series. We just have to be careful in another stage here. Because, you know, in doing so, the problem is that we have the vectors, which are 8,000 long. The vectors of simulated data, of everything, are 8,000 long, but we are starting filling them from a couple of thousand, 1900. So basically we created the vectors that are ready to host all the data, but then we start filling them only from I equal to 1900. Now we have to be careful of this, because when we compute the sum of squares is still computed on the whole vector. So we have to change something even here. And then let me make the change. So basically when we draw the plot and when we compute the sum of squares, we have to make this change. So let me define again here I equal 1900. This exercise that I am doing is also useful for you because you see some programming tricks, and then here when I write plot qt, I have to plot not the whole qt, but let me give extremes. The first is I, and the second is length qt. Or let me say, could be n delta t. That's it. And then here, when I write lines QOS, same thing. QOS I think the due punti is semicolon, but I'm not sure. Let's call it semicolon and delta t. Good. And here, again, the sum of squares, let me put I and delta t, and the QOS, again, I and delta t. So I made these changes. Okay. If we do like that, you know, it's a bit maybe confusing, because we have to remember, if we want to change the starting point of the simulation, we have to change two variables. We have to change I here and there in the bottom, because I is also the variable of the loop here, of the computation loop, so it is changed each time step by the cycle, by the loop. And therefore, at the end of the program, when we plot the graph, we have to redefine it. So let's make it in a smarter way. Let's define a variable called skip, which we skip, yeah. Let's call it sk equal 1900, and then here I can put for I in sk and delta t. It's clear what I'm doing for everybody. And now we have to change in the bottom in the plots. What I just did, let me change here. And let me change, we can change in this way. I equal sk. This should be fine, so let's save it. And now we have to upload the program in R. And last time I suggested you to select all and paste in R. Yeah.
Can I see where I should put SK in the first time?
Here, you should define, because what I did previously was to change the value of I. But then I is changed also by the loop, so it's better to define SK here at the beginning of the file, before the computation loop. Okay, as I said last time, I copied from the notepad and I pasted in R. Indeed, this can be done, but it's more practical, and I will explain you why, to do like that. Instead of cutting and pasting, just source imod.r. Why it's more practical? Because it's useful to keep the history of R clean. Because if you cut and paste, each line of the program becomes an instruction in R. So if you want to go back with the arrows to get the previous instructions, it becomes very tricky, difficult, cumbersome. And in this case, instead, the history is clean. You see that if I go back, I have my previous instructions. Okay, now, of course, we have to check that the program that we modified works, because I'm not sure. Of course, we went forward just by our perception. Now, let's make a check. And to make the check, let me now, I clean the screen, run iMod. And to run it, we need to put trial values for the parameters. So let me put 200 and then a sequence of 0.5s should work. And now the question is it working? Let's see if it's working. Yes, it seems that it's working. Of course, the simulation is not good, but it seems that it's working. Remember that if I well remember, red is observed and black is simulated. Yeah.
I get the graph, but then it tells me errore che A dietro B argomento non
Perché non ha fatto tornare il sole. Just 1 second, I try to see if I got the same error. Yeah, the problem that you get is that it got an error in the computation of the sum of squares. Let me see. Seems like there is another sign in the vector. So let me see. Okay, scribbling.
4 0.5. Cioè sono 200, 0.5, 0.5, 0.5.
La somma dei quadrati, beh, oddio, se sì, in teoria sì, però bisogna vedere se avete messo i parametri uguali, controlli cosa c'è scritto io, ok, so and let me see is, where is the code?